Hello, so today we will discuss the task downloading B++. So we have a file that has size of F bytes. We can use a simple internet tariff that can download 1 byte per T0 milliseconds, or we can use two different additional packages. We can download A1 bytes with the speed of T1 milliseconds per byte, but it costs P1 dollars or something else. The same goes for the second package. So we need to download this whole file in T milliseconds. So the whole idea is to construct the way that we can download the whole file in this time. And if there are many different solutions to that, choose the one that costs the least one. So we must print the total cost that must be the smallest one. So now we will build some model. So if we don't use any additional package, then we can download X bytes using original tariff, prepaid tariff. If I buy, for example, a first package, then I will download Y times A1 bytes using first package. If I buy the second package, I will download Z times A2 bytes using the second package. So why do I do that like that? Because here I can tell that X, Y, Z are integer non-negative numbers. So they are integers. So my goal is to minimize this function P1Y plus P2Z to minimum. So Y is number of times I buy the first package, and Z is number of times I buy the second package. Now we will build some constraints. So if I download X bytes using the prepaid, then A1Y bytes using the first package, A2Z bytes using the second package, the total download must be not less than F. Then we have time constraint. So using the speed, so T0x plus T1A1Y plus T2A2Z must be less or equal than T. So we have these two constraints, and we have this function to minimize. We can use simplex method to solve this problem, but we don't need it. So the reason why the simplex that we have is pretty simple. So we can solve it without using any additional methods. So if we construct 3D coordinate space, let's say this is X, this is Y, this is Z, then the first constraint of this one will look like that. So it will intersect 8 axes like that. The second constraint will look like that. So they will have some line of intersection somewhere here. If they look like that, it may look like differently. So the line might go like that. But along the line, you might have different values, and the borders, so the ends of these lines, have the optimal solution, one of them. So while solving this system, we will put here, in both cases, equal sign, and we will try to solve this system putting either x to 0, y to 0, z to 0. After that, we will put two variables to 0, and we'll try to solve it. So this task might not have any solutions. How can we measure that we don't have any solution? So we choose minimum value out of T0, T1, and T2. We multiply it by f. It must be less than equal than t. Otherwise, we cannot manage to download the whole file in the given time. So this is one. Another thing, we want to minimize our cost. So if we can download the whole file using just prepaid package, then the answer will be 0. So here we have a solution. If it's not completed, then we don't have, and here we have a solution of 0. If we don't have any of these situations, then we proceed to solve the system using different put variables, and then after solving them, we will get non-integer solutions. Usually we will get non-integer solutions. So what we do, we look around this point. So we will calculate this value, this p-value, our function, for each of the ending points we get, and we choose the point with the smallest value. But we must check that the whole system is okay with that, so that it is satisfying the system we have, the system of constraints. Then we calculate this function and we find the minimum value. So this point that has the minimum value, the optimal solution with integers is somewhere around it. So we must look around it. But where exactly do we look? So if we take a gradient of this function, let us say this is function cx, yz. So if we take the gradient of function c, we will have a vector of 0, meaning on axis it's 0. Then we will have p1 on y and p2 on z. If we find like GCD of p1 and p2 and divide it by that, we will have another vector that describes us the distance of one step. So if you find one solution, applying this one step, we will also get another solution that is also integer. So integer solutions lie within this distance. So we can choose them. Starting with non-integer solution, we make it integer and look around it and find the smallest value. So it requires using some loops, but still it is way faster than trying to solve it using all possible values. So this is the method to solve this task. We also have to mention that sometimes just integer solution is not enough. For example, you might have y and z that are integer numbers, a1y plus a2z are less than f, but they satisfy the conditions with the time. If you add 1 to either y or z, you exceeds f and time t. Then you find the difference of f, a1y, a2z, and you try to download this portion of bytes using either of the packages. So you want either the fastest one or the cheapest one. You check for both. Let's say you check for y. So what you do is for time, you check t0x plus t1 times a1y plus d plus t2 a2z. If it is less than t, then it is enough to download the file and it lies within this time limit. So then you can calculate your values. The cost will be p1 times y plus 1 plus p2z, because you have to pay the full price of the package even though you use just portion of the bytes this package provides. So you do similar things with z, you check with that and you find the optimal solution, and here how you finish this task.